Good day, my name is PUA KAI QIN, PG22020, and this video presentation is titled Smart Room Lighting and Safety System. Prepare for the course BTE4733 Sensor Technology. In this presentation, I will explain how a smart lighting system works using two sensors, which are the LDR sensor and the PIR motion sensor. Smart room lighting is an automatic lighting control system that operates based on environmental conditions instead of manual switching. The purpose of this system is to turn the room light on only when it is actually needed. This type of system is commonly used in homes, offices, classrooms, corridors, and staircases to improve the convenience and safety and the energy efficiency. In daily life, lights are often left switches on even when the room is empty or when there is already enough daylight. This leads to unnecessary energy consumption. Manual lighting control depends heavily on human behavior, which is not always reliable. In addition, systems that rely on only one sensor may cause false triggering, making the system less accurate. The objective of this project are to reduce unnecessary energy consumption, improve safety and convenience, and increase system reliability. This system also aims to demonstrate how multiple sensors can be integrated into one system to produce better performance compared to a single sensor system. This slide shows the overall system architecture. The system consists of two input sensors, which are the LDR sensor and the PIR motion sensor. The data from these sensors is processed by a microcontroller, which then control the lighting output such as an LED or a lamp. The controller makes decisions based on the input from both sensors. This block diagram shows how the LDR sensor and PIR sensor work together in the system. The LDR provides information about ambient light intensity while the PIR sensor detects human presence. Both signals are processed by the controller, which decides whether to turn the light on or off. The first sensor used in this system is the light-dependent resistor or LDR. The function of the LDR sensor is to detect ambient light intensity. It is commonly used in applications such as automatic straight lining, day and night detection system, and camera exposures control. Here, the LDR is used to determine whether the room is bright or dark. This diagram shows the working principle of the LDR sensor. When the light intensity increases, the resistance of the LDR decreases, producing a higher voltage output. This analog voltage is used by the controller to determine the lighting condition. The working principle of the LDR sensor is based on resistance variation. When the light intensity increases, the resistance of the LDR decreases. This change in resistance produces a variable analog voltage output. The controller uses this voltage value to identify the lighting condition of the room. This graph shows the relationship between the illumination and resistance of the LDR. As light intensity increases, resistance decreases, showing that the LDR is sensitive to light changes. In terms of sensor characteristic, The LDR detects ambient light for lightning control applications. It has high sensitivity to light changes, but its accuracy can be affected by the environmental conditions. The measurement range covers dark to bright environments. The output signal is an analog voltage. Factors that affect its reliability include sensor placement, shadows, dust, aging, and sudden changes in lighting. The second sensor used is the passive infrared or PIR motion sensor. The function of the PIR sensor is to detect human presence by sensing infrared radiation emitted by the human body. It is commonly used in the security system, automatic doors, and motion activated lighting system. In this system, the PIR sensor is used to determine whether someone is present in the room. This diagram shows that the working principle of the PIR sensor. The Fresnel lens focuses infrared radiation onto the sensor. When a human moves, the change in infrared radiation produces an output signal, which indicates the motion detection. The PIR sensor works by detecting changes in infrared radiation within its detection area. When a person moves within the detection range, the sensor detects the change and produces an output signal. However, the PIR sensor cannot detect stationary humans as there is no change in infrared radiation. This image shows that the detection area of the PIR sensor from the top and side view. The PIR sensor can detect motion only within a limited angle and distance. This explains why proper sensor placement is important for reliable motion detection. The PIR sensor detects human motion for occupancy detection. It is sensitive to movement but cannot detect stationary objects. The technical measurement range is approximately 3 to 7 meters. The output signal is digital, which a high signal indicates motion detected and a low signal indicates no motion. Factors affecting reliability includes ambient temperature, obstruction, motion speed, and sensor orientation. In order to improve system reliability, both sensors are used together. The system applies an logic, meaning the light will only turn on when the room is dark and human motion is detected at the same time. The LDR motion alone cannot detect human presence, while the PIR sensor alone cannot determine whether lightning is necessary. By combining both sensors, false triggering is reduced and the system becomes more reliable and accurate. This table shows the system operation under different conditions. When the room is bright, the light remains off even if the motion is detected. When the room is dark but no motion is detected, the light also remains off. The light turns on only when the room is dark and the motion is detected. This clearly demonstrates the effectiveness of the multi-sensor approach. During the demonstration, the system responds automatically to changes in light condition and human presence. The light turn on only when the required conditions are met and turn off when they are no longer satisfied. No manual switching is needed during the operations. From the observation, the multi-sensor system performs better compared to a single sensor lightning system. The use of two sensors improves decision accuracy, reduce false triggering, and enhance the energy efficiency. The system response is stable and consistent under the different environmental conditions. Despite its advantages, the system has some limitations. The PIR sensor cannot detect stationary occupants, while the LDR sensor may be affected by sudden changes in lighting. In future improvements, a time delay function or additional sensors such as ultrasonic sensors can be added to further enhance system performance. From a safety and practical perspective, the system operates at low voltage, making it safe for indoor use. Proper sensor placement is important to ensure accurate detection. This system also contributes to energy saving and is suitable for implementation in smart building environments. In conclusion, this project demonstrates a smart room lighting and safety system using an LDR sensor and a PIR motion sensor. The multi-sensor approach improves system reliability, reduces energy wastage, and enhances safety. This system is suitable for smart home and smart building application.